Now we're on our try it number 2. So you just saw an example of this, but now we're taking two fractions and dividing. So we have 1/4 being divided by 3/8. So we're going to draw an area model. So I'm going to get my rectangles out. Let me make them white. So I've got a rectangle. First of all, I need to find out where is 1/4. Okay, I'm going to create another rectangle that's going to give me 3/8 so that we can find out our portions. So I'm going to go ahead and divide this. And you can see I've got fourths there. So I can extend those down. Oh, that wasn't ideal. Okay, so I'll extend those down. And I've got fourths. With this one, I'm trying to create eighths. So once I have my fourths, I can divide each of those in half. I know that last line wasn't perfect, but I can divide each of those in half, and I'll have 8 sections. Okay, so now that I've got eighths, what we're asking is how many eighths or 3/8 can go in to 1/4. So I'm going to kind of shade these here quickly. So I've got 1/4, which is one of my 4 sections, and then I've got 3/8. So how many of these 3/8 are going to fit into there? Can we identify that? First of all, do we have the same denominator? You remember in the last problem, we want to make sure we have the same denominator. So in order to get the same denominator, we don't always need to do 4 times 8 and divide this into 32 different parts. If you can see, we already have a common line here. So what we're going to do is we're going to turn 1/4 into 2/8. So how many 3/8 can go into 2/8? Well, we cannot get 1. We can get 1, 2. So we can get 2/3 of that in there. So the third would have been here, right? That's what the 3/8 is. We can get 2/3 of 3/8 to go into 1/4. So that is our answer. And we can check that. But with our division of fractions, it's always nice to check it, is keep, switch, and flip. When we do that, we get 1 times 8 is 8. 4 times 3 is 12. All right, so then we ask ourselves, what number goes into 8 and what number also goes into 12 evenly? I know you all can see a 2 can. They're both even, so a 2 can go in there. But is there something larger than 2 that goes into both 8 and 12? So I'll do this 2 different ways, okay? So you're going to say, hopefully, 4. So how many 4s go into 8? 2. And how many 4s go into 12? 3. So there's our answer again, 2/3. Now, if all you saw was that these are both even, you could say how many 2s go into 8? 4. How many 2s go into 12? 6. You notice they're still even? So go ahead and reduce it again. How many 2s go into 4? 2. How many 2s go into 6? 3. Look at that. We still get our 2/3 answer. So again, we don't want you just to be able to take our fractions and do the calculations by hand. If that's all you can do, we're at a 2.5. If you can start to draw these models and show me what's happening, then you're at that 3 or above, okay? So we're really trying to get you to understand that concept visually as well as just being able to calculate it. Awesome job again. Hopefully that makes sense. If not, rewatch the video. Go through it again. Second time, third time I've seen it might make more sense.